Welcome back to section 3 of chapter 12. In this section, the next section, we are going to be looking at specific types of sequences and series. So we'll be able to focus down instead of having just the big ominous sequences and series and you have to kind of work your way through them. We're going to get a couple formulas that'll help you out a lot. So today we're going to be looking at arithmetic sequences and series. I know you might be thinking, why he's pronounced as arithmetic, it looks like arithmetic. They are spelled the same, they are different words. Arithmetic would be the noun, arithmetic would be an adjective that means arithmetic-like. So, it is basically the same, it's just parts of speech, English is dumb. Our learning targets. I can find the indicated terms of an arithmetic sequence. And I can find the sums of arithmetic series. So we have the sequence and series. Find the term, find the sum. And so we might be thinking, all right, what is an arithmetic sequence? It's a special type of sequence where each term differs by the same number, which is called the common difference. So like those sequences where it's just adding 5, adding 5, adding 5, adding 5, minus 4, minus 4, minus 4. We're just adding or subtracting to get from one term to the next. Now, we've seen some of these already, and we've used a word to describe them. Do you remember what we called those? When you're always just adding a number to get from one term to the next? Linear. Arithmetic sequences are just linears. We're working with lines today. How awesome is that? So, we have a general rule for an arithmetic sequence, which is just the equation for a line, with one slight little difference other than changing, instead of using x, we have n. We have the first term, so our term will be the first term, plus n minus 1 times d. So first, d would be the common difference. That would be the slope. Now, instead of d times x plus the y-intercept, we have x minus 1 or n minus 1, which is just a horizontal shift 1 over, which makes this, instead of the 0th term, which is what the y-intercept would be, it's the first term, which is something that we actually see in the sequence. We don't use the 0th term in the sequence. But for all intents and purposes, this is the equation for a line. And so how would we use this? Well, if we have a sequence, negative 6, negative 1, 4, 9, 14, how do we get from one term to the next? Plus 5, plus 5, plus 5, plus 5, that's D. And then what's our first term? Negative 6. That's A1. We just plug those in. I move the 5 in front because n minus 1 times 5 just looks weird. So I made it 5 times n minus 1. This is the equation. Now we had this question on the worksheet yesterday. And at that point, it's plus 5. So we have 5n plus or minus what gets us to that first term. It was minus 11. If we distributed this, we'd have 5n minus 5 minus 6 would be 5n minus 11. And so instead of having to try and work our way through it, this just gives us a really quick and easy formula to plug stuff into. Some other things that we're going to be doing with these arithmetic sequences, we're going to find the missing terms. So if we have a sequence, 7 blank 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 13, we can find the missing terms. Sometimes this will be really easy and you'll be able to just say like, oh, it's going to be 5, 7, 9. This one, I chose one that's a little bit tougher so that that's not quite so easy. And so there's a couple ways of doing it. Some ways will work if you have an odd number of spaces like we do now. It would make sense that this middle number would be the average. What if we only had 2 spaces? What if we had 4 spaces? And so a way that will always work is we know that this next number is going to be 7 plus d. And then to get to the next one, plus d. And then plus d. And then plus d will equal 13. So 7 plus 4 d's is the number of spaces plus 1. It's the number of commas. 7 plus 4d will equal 13. We can solve this to find d. Subtract 7, divide by 4, d equals 3 halves, or 1 1/2. And so if we have our space with blanks, 7 plus 3 halves, or plus 1 1/2, is 8 1/2. Plus 1 1/2 is 10. Plus 1 1/2 is 11.5. Plus 1.5 gets us back to 13. And so that's a way that works for any of these find the missing term questions. Another type of question is find the nth term. And so we could have, we know a couple terms, find the nth one, find the 11th in this case. Few ways you could do it. You could do it kind of like this, and then find d. Let's see, we have 8, and then plus d will be 9, plus d will be 10, plus d will be 11, whatever that'll be. Or another method, which that way works. Another method is we could take that general equation that we saw in the previous slide, and these n's and 1's don't have to be there. We could make them any number we want as long as we change everything. So I'm going to change the n's to 8's because we have an 8th term. I'm going to change the 1's, both of them, to 3's because we know a 3rd term. So we have A8 is going to equal A3 plus 8 minus 3 times D. Those both n's change to 8. Excuse me, and both 1's change to 3. We can plug in A8 is 13, A3 is 20.5, and then 8 minus 3 is 5. And we can solve for D, subtract the 20.5, and then divide by 5 to get D equals negative 2.5. And now we could just go from there to here. So 13 minus 2.5 minus 2.5 minus 2.5. That would work. But what if instead of looking at for A11, we were looking for A27? I wouldn't want to subtract 2.5 that many times. But we can plug it into here. This can stay A3. It could be A8 if we wanted to. As long as this number, this 3, matches this one, it's fine. And then we can change the 8's to 11's. Because we're finding the 11th term will equal the 3rd term plus 11 minus 3 times our difference, which we just found. We can plug in the 3rd term. It's still 20.5. 11 minus 3 is going to be 8. 8 times negative 2.5 is negative 20. So we have 20.5 minus 20 is 0.5, which, if you start at 13, minus 2.5 is 10.5, minus 2.5 is 8, minus 2.5 is 5.5, minus 2.5, minus 2.5. We get to the same place. So that's just another way of doing it. There's lots of ways of getting to the answer. You can pick whichever way you want. I'm just trying to show you a couple different ways so that you have more options to choose from. The last thing we're going to look at is arithmetic series. That's the sum of them. Now this is going to be very similar to something we looked at last time, because last time we had a linear series. What's the difference between linear and arithmetic? The linear, find the sum of the first n terms. The linear series was specifically 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus up to the last number. And we'd have the last number, which was n, plus the first number, times the number of numbers, divided by 2. So in this case, 9 plus 1 times 9 divided by 2, which is 45. An arithmetic series is the same thing. It's just a little bit more generalized because the last number isn't necessarily n. It's whatever the last number is. The first number isn't necessarily 1. It's whatever the first number is. But we're going to do the same thing. It's the first number plus the last number times the number of numbers divided by 2. So we have the first number plus the last number times the number of numbers divided by 2. So if we want to do an example, we have 5 plus 7 plus 9 plus 7 plus 13 plus 15 plus 17. We could go the first number plus the last number, 5 plus 17, times the number of numbers, 1, 2, 3, 4, 5, 6, 7, divided by 2. 5 plus 17 is 22, divided by 2 is 11, times 7 is 77. And so it's the same process, because if we go 5 plus 17, we get 22. If we go 7 plus 15, we get 22. If we go 9 plus 13, we get 22. And so the same process works. It's just, again, the more generalized version. Sometimes we'll be given it in summation notation. We want to find the fifth term of this. We just need the first term and the last term. We know the number of terms is going to be 5 because it's a fifth term. So let's find the first term. We just need to plug in 1. 3 times 1 minus 7 is negative 4. Find the fifth term. Plug in 5. 5 times 3 is 15. Minus 7 is 8. Add them together, which 8 plus negative 4 is 8 minus 4, times 5 divided by 2. And our sum is 10, which may seem low, but remember we're adding some negative numbers in there, so that's going to help bring it down. And so that's what we're doing today. It's working with lines, and it's working with lines. Who would think that we'd be working with lines at the end of Honors Algebra 2, yes? Anyway, I will see you in class, and enjoy the rest of your day.